Next Monday, we will not be having a formal Zoom session. What we will be doing instead is I'm using that as an opportunity to give you time to take your exam. Your exam is in a take-home style. So what it'll look like is from 7 to 7 on Monday, I will have the exam up in Blackboard. It'll be in the button that is marked exams. You have 12 hours in which you can download that exam, and then you have to upload the finished exam into Gradescope by 10 p.m. So if you download it at 7 p.m., that still gives you 3 hours to take the exam and upload it into Gradescope. That is as good as I can do given the parameters of what a take-home exam ultimately means. Now, some provisos in here. I will be giving you all of the tables and charts, so I will be giving you a clean copy of the periodic table. I will be giving you the equation sheet. I will be giving you any other relevant information that you might need. Key thing among all of this is you have to work individually. And this kind of sounds like a no-brainer, but there have been occasions in the past 2 years where I've given take-home exams like this, and students have definitely not worked on their own. And the way I can usually tell is the exam copies are exactly the same. They do the exact same set of steps. They get the exact same answers, and they don't get 100%. And usually when the question that they don't get right is one that they just fail spectacularly on, and I can usually figure out, okay, how did they come up with this? And why are they the only two that came up with this particular method? So if you do not work individually, if there is evidence of collusion, of working together, that falls under the purview of academic dishonesty, and that requires an investigation. That requires a viewpoint where I have to get the dean of the college, Dean Kaufman, involved, and potentially the dean of students' office involved. And that would pretty much put an end to the idea of a take-home exam. So if this is something that's attractive to you, where you get a little bit of extra time, a little bit more freedom, don't mess this up by trying to get an extra edge on people. Because we can do a proctorio exam and have everything crammed into a 1 hour session that everybody has to do at the 9 o'clock hour on the next exam date. I don't want to go to that system. I think this is a fairer system to you, and gives you the extra time that you need. But if that's the system we have to go to make sure that everybody's working fairly, then that's what we'll do. So again, you can download it between 7 and 7. So if you're an early riser, you can get up a little bit early and actually have the whole thing done by the time it comes to this class. If you find that you need more time, or you just want to work at it throughout the day, just make sure that it's in Gradescope by 10 o'clock. Last point of order with regard to that, the preferred method of submission is that you print it out and that you write your answers on the page. It's a lot easier for Gradescope to capture your answers. It's a lot easier for me to determine your answers and go that way. If you don't have that access, what I would do is get a piece of paper and basically make an answer sheet and just write down, okay, multiple choice. Number 1 was B. Number 2 was A. Number 3 was D. And then when you get to the short answer sections, just leave yourself enough space to write out your short essay or do your calculations. One of the things with this format is that to ensure that you actually know what you're doing, there will be points associated with showing your work. So in the calculation section, if you just jot down an answer, that will only earn you partial credit, even if it's correct. And the primary reason there is for conversion questions like what we saw in chapter 1, those are Googleable. And I want to actually make sure that you know how to do it. Anybody can Google conversion. That's not the point. The point is, do you understand the technique? So, getting the correct answer is part of that. But also involved in that is getting the correct significant figures, getting the correct unit, and showing your process for how you got from the first unit set to the second unit set. So if you just give me a bunch of answers, I can only give you partial credit based upon whether or not they are correct. All right, any questions so far?
I have a question.
Go ahead.
You said that the periodic trends post-lecture was due last night, right?
Yes.
When I go in smart work, I'm seeing that it is due tonight. So I'm kind of confused.
Okay, let me double check it. Okay, actually you are correct. I misspoke there.
Yeah, so I was kind of confused about that because I know I saw that it was due tonight.
Okay, no, thank you for pointing that out. My original notes had to do Sunday night. I forgot that I moved it to Monday because we did not actually talk about it. So no, you are absolutely correct.
Okay.
So yes, let me change that on here so that in case anybody views that in YouTube later, they will have the correct information. All right, any other questions? All right, Jacob, what do you mean, seconded? Okay, thank you. All right, so let's talk about our quiz for tomorrow. Now, in the quiz, there are some definite sections, some things that you're going to want to know how to do. All right, so in the quiz itself, the quiz is a proctorio quiz, just like your other ones have been. So you are going to have to have the normal webcam set up and whatnot. As far as the quiz goes, it is broken up into a couple of different sections. So get the whiteboard back up here. First thing that you should know, there are no calculation questions on this quiz. So all that stuff that we did with regard to light and energy, the Balmer lines, the Rydberg equation, none of that's going to appear on this quiz. This quiz is going to be largely conceptual in nature. Now, that's not to say that on the exam you won't find one of these kinds of questions. But for the purposes of this quiz, we are not going to be doing that. You're not going to find any of these kinds of questions in there. What you're going to find instead are, again, a number of questions regarding concepts, because this is a very concept-heavy exam, or a quiz rather. So that's the first thing that you should know. So what concepts do you need to understand then? Well, you're going to need to understand the fundamental concept behind quantization, the Bohr model, quantum mechanical model of the atom, so you'll need to be able to explain these concepts. So what is quantization? How do we use quantization to apply to the Bohr model? What does the Bohr model tell us? What information can we get from the Bohr model? Why is the quantum mechanical model the better explanation of atomic structure compared to the Bohr model? And remember, the real big difference between the Bohr model and the quantum mechanical model was in the interpretation of those orbits. So the Bohr model said that the electron was going around the nucleus in an orbit. The quantum mechanical model says that it's orbiting in a wave, and that those waves correspond not to specific orbits, but orbitals. And so getting into our quantum numbers and our electron configurations and so on and so forth from there. So being able to explain those things, being able to explain the differences between some of those things, that's going to be part of what you need to do. In here, you'll also find something about quantum numbers. In particular, assigning quantum numbers to specific orbitals and sublevels. So what I mean by that is if I give you n is equal to 4 and L is equal to 2, you should be able to tell me that this corresponds to the 4D sublevel. And you should be able to depict in some kind of way what that looks like. So in some kind of form or fashion, you're going to have to show that you know that d orbitals have some kind of a clover leaf shape. And obviously you'll be able to draw that a lot better than me, because you'll have the benefit of pen and paper as opposed to mouse and computer screen. Something else that we can pull. We can also talk about electron configurations. And on this, I want to add a subnote. And that subnote is read the question carefully. Some of the questions ask for noble gas configuration. Some ask for complete configuration. You will lose points if you give the wrong one. Then the last thing that you really want to focus on are periodic trends. And for those, you really want to focus on the first three: atomic size, ionic size, ionization energy. Now, in total, there are 6 questions on this quiz. And I can tell you one of them is of this kind, one is of this kind, and then there are 2 each of those kind. That's where your 6 questions come from. So that's your chapter 3 quiz. Now, according to the quiz directions, I believe you get 35 minutes to take this quiz. Yes, 35 minutes. One other really important note: one question requires you to draw on a separate piece of paper and upload as a picture attachment. So make sure that you have some sort of camera device at the ready when you do that. So whether it's your phone or a tablet, or your webcam, something that'll allow you to take the picture of the required object and save it and upload it. Hopefully that's not too much of an ordeal.
So I have a question. So so say I scan it in as like a PDF.
Yes.
And send it, I have to send it to my email to get it on my computer. Can I open my email while I'm doing that?
I believe so. Like I said, I've jiggered with the Proctorio settings enough that it should allow you to download things and open tabs specifically. If we run into that problem, hopefully we get to it soon enough that I can make an adjustment and fix it. But yes, you should be able to do that.
Okay.
And like I said, if this happened in one of my labs last week where I had a similar kind of question, and it got the student tried to open the dialog box to upload his answers, and it kicked him out of the test for doing an illegal action. He contacted me, and we fixed it within half an hour. So hopefully it doesn't come to that. If it does, like I said, I'll double check the settings this morning and make sure that it allows you enough degrees of freedom to take care of that. Like I said, we've been experimenting with some different things. Anytime we have to draw something, Blackboard just doesn't allow for that. And so we were either pushed into a grade scope direction, which I really don't want to go into, or we just have to kind of monitor and adapt within Blackboard. And that's the direction I would prefer to do. So yeah, the next few chapter quizzes are going to have questions like that, because it's going to require you to draw things. And the easiest way to draw things is to have you draw them on a separate piece of paper, and then capture the image in some kind of way, and upload them. And yes, Proctorio, with the settings we've had in the previous quizzes, Proctorio has not wanted us to do that. But again, I'm pretty sure I've shut off all of those settings. We'll see. Like I said, I'll double check again and make sure that you're allowed to do the things that you need to do to set the exam appropriately.
I have a question.
Go ahead.
I'm still kind of confused about how we upload this picture thing. So is it that, okay, if we get a question, right, about the drawing thing, so like we have to like write our answers, would it have like the part where we could click to upload the picture and everything like that? Is that what you're saying, right?
Yes.
Okay.
Yes. So let me see if I can pull a question like it,
Okay.
and show you what one of the examples is. Okay, this will take just a second. All right, here we go. All right, I can't show you in the chapter 3 because the chapter 3 quiz is already set up in Proctorio, and I'm not allowed to access Proctorio exams as a student. Just that's one of their ground rules. But all right, can you see this is a version of the chapter 4 quiz, and most of the stuff isn't going to be relevant to you for now anyway. But if you look at question 6 here, question 6 is a similar kind of question to what you would see tomorrow, and it's real simple. On a separate piece of paper, draw It's not going to say the Lewis structure tomorrow, obviously. It's going to say something else. But it's going to say, on a separate piece of paper, draw the draw an atomic orbital that represents n equals 2, L equals 1. Take a picture and upload it here. Only hand-drawn submissions will be accepted. So what you do, you draw it on a piece of paper, you take a picture of it, you email it to yourself, or if you can, you upload it directly into your computer somehow, and then you click on this Browse My Computer button. And it'll bring up, a dialog box asking you which file you want to upload. And then you just choose, okay, I want this one. And it would set that in there. So that's all it would take. And so the big concern obviously is making sure that you have access to be allowed to access your email, to access your whatever, so that you can properly upload that picture. And that's also the reason why this quiz is a little bit longer than the other ones, is because of the timing. It's going to take you a little bit more than a couple of minutes to do that problem and get it uploaded correctly. Any other questions? All right, so we spent the first half an hour talking about the quiz structure itself. What questions do we have about the topics on the quiz? We've got about 20 minutes. What questions can I answer for you regarding these 4 topics?
Can we go over a Bohr model versus quantum mechanical model?
Sure. So remember, the primary difference between the Bohr model and the quantum mechanical model was the Bohr model specifically stated, I've got my nucleus in the middle, I've got my energy levels ringing around that nucleus, and each one of those energy levels had a set specified amount of energy. And we could quantify those energies. And so the Bohr model really was set up and did a very good job of explaining the spectral lines for hydrogen. Remember, we had the Rydberg equation. Rydberg equation was able to predict wavelength based upon the electron transitions. Problem was, if we didn't have hydrogen, if we didn't have some other kind of atom that had, 1 electron, it didn't work. The lines became more confused. The Rydberg equation was less predictive. What the quantum mechanical model did was it said, electrons do not travel in circular linear paths, meaning they don't go in this direct orbital around the nucleus at that particular energy. Electrons instead travel in circular wave paths. the energy of an electron can be predicted using the Schrödinger equation. Now, we didn't talk a whole lot about the Schrödinger equation because, well, frankly, the math behind it is way more complicated than we could ever begin to fathom. But what we could do is use the net benefit of the Schrödinger equation we can use the Schrödinger equation to figure out the electron's location by putting it, instead of in this circular orbit, by putting it in this three-dimensional space called an orbital. And the orbital predicts, okay, from a probability standpoint, the electron is, let's say, 99% likely to be in this shape. And so as a result, we got a bunch of different shapes. We got the sphere for S, we've got the dumbbell for P, we've got the cloverleaf for D, and then we've got the dragonfly for F. And you know, you can be very, very certain that I'm not going to ask you to draw an F orbital in the quiz tomorrow. You're gonna have to draw S, P, or D. It's just a matter of knowing when and what quantum numbers predict your shape and size and so on. And so that's the primary difference between the two. The Schrödinger equation and the other quantum mechanical constructs harken back to the Bohr model. The Bohr model is important because Bohr model kind of gave us a starting point for the idea of putting together the concepts of quantization and this wave particle duality that exists in electrons. Because remember, the photoelectric effect said that we had wave particle duality with light. The de Broglie equation told us we had wave particle duality in matter, but that really is only effective if our matter is very small. And electrons certainly fit that billing, where they are so small, their projected wavelengths match up to roughly the size of the atom. And so as a result, their wavelengths, in order to maintain consistency of energy, have to be at a certain resonant frequency, which is why the energy levels inside of the atom are at very set values. All right, does that make sense? Can we see the difference between the two now?
Yeah, thank you.
Okay. All right, what else can we talk about?
Can we go over electron configuration, please?
Okay. What specifically?
Okay. So what I'm having problems with is trying to figure out the different shells, I guess. Like, I still don't understand like how you figure out, okay, if like, I don't know, like to figure out the full electron configuration for certain elements, like I'm still having problems and like how to actually use the periodic table itself to figure stuff out. Like,
Okay, so the big idea that we have to wrap our head around here is that we can break off the periodic table into zones based upon the location of the element that we are studying. And so there are 4 different zones because there are 4 different types of sublevels. So this first zone, which includes helium in this spot right here. Remember, helium, because of its size, helium is going to have electrons in the 1s orbital. So the the 4 zones, we have the S zone, which is the first 2 columns here because there's 1 s orbital and each orbital contains 2 electrons. So 2 electrons in these 2 columns, 2 elements in these 2 columns, it matches up. The second zone over here is the P zone. P sublevel has 3 orbitals. 3 orbitals times 2 electrons each is 6 electron capacity total. There are 6 elements in this block. The third zone is the D zone. The D zone, we have to take into consideration it is offset by 1. So whatever the period number is, the D sublevel there is 1 less. So that means that the first row here is actually the 3D. This is the 4D below it, the 5D below that, and the 6D below that. And then the last zone is the F zone, and it is so high in energy that it is actually offset by 2. So even though the lanthanides actually belong here in the 6th row, these are actually representing the 4F, and the actinides are representing the 5F orbitals and sublevels. So what it comes down to is recognition of, okay, where am I going and how do I get there? So let's just say, for example, that I want to find the electron configuration for, well, let's pick on one we haven't done yet. Iridium. If I want to do the electron configuration of iridium right here, well, there's a couple of things that I need to do. First of all, I understand that every single orbital, all the way from helium to this last block, is completely filled, because all of these electrons have to be used up. And so that leaves just this last block. So if I'm writing out my configuration, I can start at the very top, 1s, 2, because again, if I get confused on how many electrons I need to put in each sublevel, I can always just count the number of blocks in the number of elements in that particular block. So 1s2, 2s2, 2p6, 3s2, 3p6. Now I'm here. 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2. Now we jump down to the 4f, 4f14. And now we've covered all the ones that are filled. The only one that is unfilled is the 5D. The 5D, which contains iridium, does not have a completely full subshell. And so how do I figure out how many electrons go into that 5D? I have to count. So starting with lutetium here, 1, 2, 3, 4, 5, 6, 7. Iridium is the 7th in that block. Its last configuration would be 5D7. Now, that's a really big, long electron configuration. So how do I turn it into a noble gas configuration? Well, remember, for noble gas configuration, I want to go backwards to the nearest noble gas. Why backwards? Because the noble gas configuration is going to tell me, okay, this noble gas, this contains all of those electrons for all of those orbitals that are filled and are in lower energy than my most energetic electrons. And so of the 77 electrons in iridium, 54 of them can be accounted for. We can account for them by taking xenon, putting it in brackets and saying, okay, the first 54 electrons in iridium are covered by the electron configuration of xenon. If I wanted to write out the electron configuration of xenon, I could, but we generally understand what it is. It's not changing. It's not going to be anything out there or different. All that's left is what is after xenon. So there are 23 electrons between xenon and iridium. Where are they? Well, from xenon, I can see I've got 6s, so 6s2. Now I need to jump down to the 4f, 4f14. That takes care of the green block here. And then now I've got the 5D block again, and there are 7 of those to get to iridium. And so I take the 54 of xenon plus these 2, that's 56, plus these 14 is 70, plus these 7 would be 77. That's 77 electrons, which matches iridium's atomic number. So really the whole thing about electron configurations is we have to be able to pinpoint what it is that we are ending at. If we can pinpoint the sublevel that we are ending at, then it's just a matter of filling up everything that preceded before. And so that's where the periodic table really comes in handy, because you can look at it and say, oh, okay, I end in 5D. That must mean that everything else that came before it is completely filled. And I just match up the group, the period number, with the block. So 1 with S, then 2 with S, then 2 with P, then 3 with S, then 3 with P, then 4 with S, then 4 with D. But I gotta remember, D, I take 1 away from the period number. So instead of 4D here, this is 3D. Then 4 with P, then 5 with S, then 4 with D, 5 with P, 6 with S, go down to the F block. Remember that F is n-2, so that 6 becomes a 4, 4F, then 5D, and that's where I'm home. So it's a little bit tricky, but this does read like a roadmap if you've got it blocked off correctly. And so that's what I would encourage you to do, is make sure that you've got yourself a visual. If you've got your periodic table that we wrote on, and kind of blocked off in class, I don't care if you use that for the quiz. All that I would ask, and this would just be so that we can throw Proctorio off your scent, is if you use it, hold it up to the camera so that that I can see that that's what you're looking at, so that if Proctorio flags you for, having too much eye movement or something crazy like that, I at least know what you're looking at. All right. Any questions before we go?
When dealing with the electron configurations, how would we determine which configuration, say spin up or spin down, would be of higher energy?
Well, by convention, spin up is the first electron that goes into an orbital. So that would assume that spin up is of lower energy.
Okay, thank you very much.
Is that something you're going to see tomorrow? No. But the convention would tell us that that's the case. All right, anything else? All right, if you want to rewatch this, it'll be up on YouTube in about an hour or so. I will also be recording my 12 o'clock, just in case they have different questions. If you want to check that one out as well, that'll be on YouTube probably somewhere around 2 this afternoon. I don't usually record the afternoon session, but since it's a study session, they might have different questions. It's worth the time to do the recording. Otherwise, that's all I have for you. I'm actually a couple minutes over, so I don't want to keep you from getting to your next class. But feel free to reach out to me during office hour or otherwise, and I'll be happy to answer your questions. Have a good afternoon.